chemical reactions, and I have them right here. So the first type, you'll notice that we have the reactants always on the left side of the arrow and the products on the right side of the arrow. And they are not balanced. So we'll learn that next. But first we're just going to focus on the types of reaction. And here I've drawn CH4, which is natural gas. It comes out of the Bunsen burner, it comes out of the stove, plus oxygen. You cannot burn anything without oxygen. And combustion is the chemist's way of saying burning. So type 1 is a combustion reaction. When you burn a hydrocarbon, which means it contains carbon and hydrogen, so it's a pretty clever name, you always get CO2 and H2O. If you are wondering why you get carbon monoxide coming out of your car, it's because it's still a combustion engine, but it operates a little bit differently, so the oxygen levels stay lower, so you don't have an explosion. And when oxygen levels are low with a combustion reaction, you get carbon monoxide. But when you're burning a candle, when you're burning oil, when you're burning wood, paper, you're burning CO2 and H2O. So what you really look for with a combustion reaction is one of the reactants contain oxygen. Even many metals will combust. They burn pretty well. Magnesium, for example, is used in old flash photography, and it gives off a really bright light. Combustion reactions are exothermic. They release a lot of heat. The next type of reaction, you'll notice I have a metal by itself. You'll either see a metal by itself or a halogen by itself. When I say halogen by itself, it's still a diatomic halogen. But, so it'll be Cl2 or Br2. But it will displace the other one. And by displace, I mean, here you have silver and it's paired with nitrate, so you have an ionic compound. But in this particular reaction, magnesium comes and exchanges electrons with the silver. And so silver becomes by itself, and magnesium is now paired with nitrate. So what you look for with a single displacement reaction, that's what these are called, single displacement, is you look for something by itself, and then you look for a pair, an ionic compound typically, and it could also be an acid or water, but usually ionic, and then you see something by itself, and it forms a new ionic compound. This is also known as the home wrecking reaction, because you have something by itself, it steals a partner, and leaves the other one alone. The third type of reaction is where you have two things, and they combine to form one. So this one is a pretty cleverly named too. It's combination, because you just combine two things. Also known as synthesis. So combination and synthesis mean the same thing. Again, these are not balanced. We will put coefficients in front. But right now we're just trying to recognize the reaction. So we see two things coming together to form one. Combination, also known as synthesis. The next type of reaction starts with one, it's the reverse, and you have to put some form of energy in. It might be heat, it might be light, some form of energy, and it will decompose it. And you might see this over the triangle, this means heat, you might see this means light. And so you see one thing breaking apart into two or more things, and that is called a decomposition. And then the last type of reaction, you have two ionic compounds. And notice they're both marked AQ, which means aqueous. Ionic compounds are typically dissolved in water. And they switch places. So this would be like that TV show White Swap. And the two on the outside and the two on the inside come together. And one of them has to form a solid, liquid, or gas, or the reaction will not go. Same with the single displacement. Not all single displacement reactions will go. The metal that is all alone has to really want to lose electrons to go. We'll come back to this. So again, we're just focusing on reaction types. When you see an ionic compound form a new ionic compound, and a new ionic compound, that's called double displacement.